Hello again, here's part 2 of the week 3 assignment. And here we are back on this fourth page, part 2, even and odd functions. And so let's talk a little bit about even and odd functions. The definitions are written down here. A function is said to be even if its graph has symmetry with respect to the y-axis, and odd if its graph has symmetry with respect to the origin. Again, if I make some sketches, a graph that has balance with respect to the y-axis rather, this is what an even function is going to look like. And the characteristic is that if you found a point on here, xy, there'll be a reflected point on the opposite side of the y-axis, right angle and reflected over here, that will have the same height but the opposite of the x-coordinate. If you think about that, you can grab any point, even a point over here in a different quadrant, and there'll be a reflected point on the other side of the y-axis with the same second coordinate, but the opposite rather, of the first quadrant, of the first coordinate. An odd function, a little bit weirder. This is going to be one that has symmetry with respect to the origin. I didn't draw that particularly well. And any point on here at xy is going to have a reflected point straight through the origin, because this is symmetry with respect to the origin, and this is going to have coordinates that are the opposite. Both of the x and the y coordinate will be opposite. Think about that. If I pick a point here, it's going to have a reflection down here. And if this is a comma b, this will be opposite of a and opposite of b, whatever the signs are. Okay, so that's an odd function. We don't have a name for a function that has symmetry with respect to the x-axis, because those will fail the vertical line test, if you think about it. Okay? And then I think the trickiest thing about this, we ask you to go back through the 6 elementary functions and just say which ones are odd or even. Some might be neither. And this is just based on your seeing the symmetry. But then we say, how about determining if a function is even or odd algebraically? And this is a tricky kind of homework question that you'll encounter in my math lab. So for example, suppose we're looking at g of x equals 1 over x cubed, and posing the question, is this even, odd, or neither? Because obviously lots of functions will have none of those symmetries and be neither even nor odd. What the test says gives you these kind of look like hard to remember formulas. If f of opposite of x is equal to f of x for all x in the domain, then it's even. If f of opposite of x is equal to the opposite of f of x, then it's odd. The thing that the two tests, algebraic tests, have in common is this first side, this f of opposite of x. So the key to doing these tests is to start with inputting the opposite of x into the formula, and then simplifying to see if you can either get back to the original function formula showing that it's even, or the opposite of the original function formula showing that it's odd. So here I'm going to input opposite of x. Every place I see an x in the formula, I'm going to put in opposite of x. And then I'll simplify or clean this up if I can. Let's see, this is 1 over. If you cube the opposite of x, you get the opposite of x cubed, right? Opposite of x times opposite of x times opposite of x will be the opposite of x cubed. And this sign happening in the numerator or denominator of a fraction could be anywhere in the fraction, or it could be on the entire fraction, which is convenient in this case, because I think I'm seeing that the formula I get when I input opposite of x looks a lot like the original, except it's got an extra minus sign on it, right? So this is just the opposite of this stuff. In other words, the opposite of the original function formula. And this is one of our tests. You just start with the g of opposite of x, or f of opposite of x, put in opposite of x, and then work with it to see if you either get back to the original function formula that you were given, or its opposite, or neither. If you come back up with the original, it's even. If you come up with the opposite, it's odd. If you come up with neither one, it's neither. So this is an odd function. And you get a couple of tests in here. You use it on one of the elementary functions. In fact, there's one that we already graphed. And you use it here on this guy to see if it's odd or even or neither. Let me take a look at the symmetry on my calculator, see if you believe this. So if I go to my y list, I may already have it in here. I do. This is my example, right? 1 over x cubed. So I already have that in my calculator. And if I graph that function, it looks kind of like this. And do you believe that that has symmetry with respect to the origin and is therefore odd? You know, so if I had a point here, my scaling's a little funny, but if I had a point here, for instance, and I looked for its reflection through the origin, yeah, I'd have another one here. Or another way to see symmetry with respect to the origin is if you took a piece of this graph and you folded it over the y-axis and saw its image, and then you folded the image over the x-axis, it would land on the rest of the graph. Okie doke. The next thing, the next page in this assignment is a piecewise defined function. So let me come back in part 3 to talk about that. See you in a minute.